Hello, this is going to be my walkthrough video for the review of distance of 2 points and Pythagorean theorem. So this first problem we're going to look at, draw a right triangle and label a hypotenuse as C. Okay, I know hypotenuse is always across from C. It says, does it matter which sides are A and B? A and B can be switched. So as long as A and B are not the hypotenuse, you are good to go. Number 2, how is the Pythagorean theorem similar to the distance formula? So if you have 2 points, you're going to use the vertical and the horizontal to find the distance, which creates a right triangle, where when you do Pythagorean theorem, we've got a right triangle with 2 sides, and we're finding C. So you can see they're both create right triangles, both right triangles. Distance has to subtract. Where the Pythagorean theorem, you already have the lengths. So they are similar though, and in general, distance is like finding only C. So distance is just like finding C because it is like the hypotenuse of a right triangle. Okay, so we're going to do some distance practice, just finding the distance of 2 points. So we're going to find the distance of 2 points. So if you forgot how to do that, what do we want to make sure we do? We're going to take the square root and we are going to subtract those x's and then subtract the y's. Then we're going to add them together and take a square root. So what do we want to make sure that we do though is that we line them up. So I don't want to do 4 minus 7 and then 7 minus 1. I always got to do, if I do 4 minus 7 here, then on the other one I have to do 1 minus 7. To line up the 4 and the 7 and the 1 and the 7. Sorry, this 4 should be connected to the 7. 4 to the 7, 1 to the 7. Excellent. Okay, so what's going to happen here? Negative 3 squared plus a negative 6 squared. And we got 9 plus 36. We got a square root of 45. 15 and 3. 5 and 3. I think I've given you this problem before. And we get a nice 3 root 5. Over here, we're going to do the same thing. We're going to subtract those x's. So negative 3 minus 1 squared. And then 6 minus negative 3 squared. The other way you could think about it is just how far is it from negative 3 to 1? Well, that's a distance of 4. How far is it from 6 to negative 3? Well, that's a distance of 9. And then we're just going to square them and add them up. And get, look, what was that, 97? And you can't simplify that. So we're just going to stop. So you are going to have to practice those roots. If you're stuck and you just are leaving it as full roots though, you know, that's okay. Maybe I'll do another video on just roots by themselves. I mean, I did, but you know, whatever. Okay, either way. Moving on, we're going to do some Pythagorean theorem now. In Pythagorean theorem, we got to figure out what are we missing. So now we're figuring out what we're missing. So we know the base of the triangle is 6 and the height is 8. So my drawing sucks then. I need to have the base be shorter than the height. And the height is 8, which means we have A and B. So we don't have C. So we're going to find that A 6 squared plus 8 squared equals C squared, or A squared plus B squared equals C squared, right? And then we're going to add those up. C squared. So 100 is equal to C squared. Take some roots to get rid of that power 2. And we get that C is equal to 10 units. If they don't say how much the meters or feet, just put units. Alright, number 6. You've got a hypotenuse of a triangle is 9. The height is 3. So hypotenuse, we know hypotenuse is always C. So we're going to call 3A, and we don't have B. So 3 squared plus b squared is equal to 9 squared. 9 plus b squared equals 81. Subtract 9 to both sides. B squared is equal to 72. And I could take a 36 and 2, 4 and 9, 3 and 3, 2 and 2. So pair 2s, pair 3s, left over 2, 2 times 3. Pairs on the outside, leftovers on the inside, 6 on the outside, 2 on the inside. And we've got units again. So there is a couple Pythagorean theorem problems. Always look for what do you have. Do I have A, B, C before you proceed on. Okay, and then we're going to have a couple Pythagorean theorem problems that are just, pictures. So we've got pictures, and we've got to figure out the context here. So I always just mark them up. Okay, across from 90 is where my C is, so I know these are A and B. Across from my 90 is where C is, so I know these are A and B. So let's do this. For number 7, we don't know C, so we have 7 squared plus 9 squared equals C squared. 49 plus 81 equals C squared. 130 equals C squared. Let's try to take this apart. 13 and 10, 2 and 5. I can't do anything, so we are going to say C equals square root 130. For number 8, we don't know what A is, but we do know what B is. It is not C, it is 3. Look at that picture again. We got 3 squared plus C squared, oh my lord, is equal to C squared, and we know that C is 13. Let's rewind that. We don't know A squared. We do know B is 3, so 3 squared. We also know C, which is 13 squared. So A squared plus 9 is equal to 169. Subtract 9 to both sides. A squared equals 160. Get a nice 16 and 10 out of this. 5 and 2, 4 and 4, 2 and 2, 2 and 2. Remember, you can stop at those 4s if you know how to do that. But if you don't, I got 2 pairs of 2s when I take this root. So I got 2 pairs of 2s, a leftover 2 and 5. I'm going to have 4 square root of 10 units. I'm probably going to put some units in on these before I post